start. Okay. झालं ना लेक्चर तिकडचं अटेंडन्स वगैरे? Okay. So we'll start without waiting for much time. Okay. So what we have discussed last lecture, we have discussed the types of data structure. Yes. Okay. We'll just quickly take a glimpse of it, and then we'll start with the remaining part. We'll just see this diagram only. No need to. Okay, so we are here. Okay, so basically what we have discussed in last lecture. Am I audible clearly? And screen is visible?
Yes, sir.
Thank you. So basically we have started with this topic, types of data structure. Okay, so we have primitive and non-primitive data structures. In primitive data structures we have only the basic data types that we have. Non-primitive, that are derived data structures that we have. Okay, so where there are divided into linear data structure and non-linear data structure. Okay, so these are the few types we have gone through. Again, with this we have seen a few more types related to your non-linear data structures, that is static data structures and dynamic data structures. Okay, so that too we have gone through. We have also seen some characteristics of data structures. What are the different characteristics? What is the exact need of the data structure that we have? Okay. Then we have seen persistent and ephemeral data structures. Okay, so that we have. Okay, dynamic, static we have seen. Okay, and finally we have seen operations on the data structures. Okay, later we have seen in last lecture that is what is algorithm, what are the main characteristics of algorithm. So for dealing with any of the algorithm, so you should be stick with these 5 characteristics. Any algorithm should have, okay, at least one output. There is no restriction on input can be 0 or more. Definiteness. Okay, so every instruction which we are going to write, that should be means it should be clear and it should be unambiguous. Okay, so whatever you are going to write, okay, so suppose any printf statement you have to write. Okay, so suppose for if you are working with some software, okay, and you have to log an error, that is divided by 0 error. Okay, so that error comes in your program when you are making any number is going to be divided by 0, so it is going to give us the error that is divided by 0. I think you are aware about that. Okay, so if you have to log that error or if you have to handle that error, okay, so in that case you should be definite, the code should be written in a definite and unambiguous way, so that the denominator should not be 0. Okay, so it should not like that you should try with another denominator. Okay, so denominator is incorrect. Instead of, you must be specific one. Okay, so that clear and unambiguous steps you have to follow. Finiteness, it should your program should terminate in finite number of steps. And effectiveness, okay, so every statement must be sufficiently basis. Okay, so that should be effective. Okay, so that anyone can what will say carry out that particular instructions in a program. Okay, so that we have seen. Okay, then the two very main designing tools for your software, okay, that is flowchart and pseudocode. Okay, so that we have gone through. Okay, so as we have discussed yesterday, the today's agenda for the lecture is to work with the performance analysis of your program. Okay, so what exactly performance analysis is means? Okay, so how you judge your program, okay, whether that program is what will say efficient than any other program. Okay, so what exactly what different parameters we have to consider. Okay, and how to calculate those parameters. The main task is to that we have to calculate those parameters. Okay, so whenever it comes the performance of a program, okay, so you know very well that it depends on memory and time, okay, that is needed for your program. Okay, so suppose if you are going to write a program for string operations. Okay, so where there will be you have to make a concatenation of string, you have to make a reverse of a string, and a number of steps you have to perform. Okay, so in that case memory required to store that string. Okay, so that memory we have to focus on. Okay, so that memory may be compile time memory or it may be a runtime memory. Okay, can anybody tell me what is the difference between compile time memory and what is runtime memory? Yes. Hello. Compile time memory allocation and runtime memory allocation. What do you mean by that? Okay. So Compile time memory means what? If you are going to make int a is equal to 20, that is a compile time. The memory is allocated at compile time. It won't be going to change at runtime. Okay, so that is not going to change at runtime. Okay, but runtime memory allocation means what? There are some dynamic data structures. Okay, so where you will allocate the size runtime. Okay, so suppose if you have declared an array. Okay, so basically you may say that array is also compile time memory because you are writing a of 100 directly. Okay, but whenever we'll go for some advanced data structure like list, okay, so there we are adding the data runtime. Okay, so it's not a compile time, we are going to add the data runtime. Okay, so I think one concept we have seen in structure pointer concept. Okay, so where we'll create the object of the structure runtime. Okay, so on the basis of that we'll create runtime memory allocations. Okay, so the performance will directly depend on your compile time memory and also runtime memory. Okay, and time is that the time of execution. Okay, so the time of execution we have to consider. Okay, so these are the two very important parameters that we have to calculate. Okay, that we have to consider and calculate while evaluating the performance of the program. Okay, so basically we use two approaches to determine the performance of the program. One is analytical and experimental. Okay, analytical means why means you just what will say analyze your program. Okay, so you can have some experimentation, you have perform some measurements. Okay, so by which you can go with that. Okay, and experimental means what? We'll directly work with adding some what will say elements in your program. Okay, so that will have. So basically there are two things that we have to consider, that is space complexity and time complexity. Okay, so basically we'll just see the space complexity concept first. Okay, then we'll see the time complexity concept theoretically, and then we'll go in detail how to calculate those things. Okay, in between if you have any doubt you can ask in between. Okay, so basically as we have seen space. Okay, space means it is the amount of memory it needs to run the it needs the program to go to completion. Okay, so that how much amount the space is needed. Okay, so space is again divided into two different parts. Okay, that is instruction space and data space. Okay, so what is instruction space? Basically it is the space needed to store the compiled version of a program in program instructions. Okay, so means what? Whenever you run your program, you know the steps of running that program. Okay, so if you remember what is the first step, so you are going to write the program in your text editor. Okay, so if you remember in first semester first unit, we itself have covered a few steps. Okay, so like compilation, linking, loading. Okay, so likewise if you heard about that words. Okay, so first when we write the program, so that will be a one text file. Okay, so whenever you are going to compile the program, so it will create an object file of that program. Okay, so that object file is created. Okay, so not going into that much detail, you can consider that whenever you run a program. Okay, so that program copy is generated, which is called as the compiled version of a program. Okay, so that is called as an instruction space. Okay, so how much memory it requires at compile time. Okay, so that is compiled version. And data space means what? It is a space needed to store all constants and the variable values. Okay, so that we have that particular thing. Okay, so for any program, okay, so we can just summarize this. Okay, so for any program, suppose if you written some program. Okay, so of suppose these many lines. Okay, 10 lines we have. Okay, so 1 2 3 4 5. Okay, so these many lines of program if you are written. Okay, so that program once you run that program, that should the program means compiler should allocate the space to that particular program, so that we can say it as an compiled version of that program. Okay, so that we have, that is compiled version of the program we have, that is in memory. Okay, so that we have. And in that program, suppose at few lines you have declared integer a, integer b. Okay, character, arrays and structure. Okay, so that will be a constants we have in a program and variables we have a program, so that will be called as a data space of your particular program. Okay, so these are the two things, instruction space we have and the data space we have. Okay, so again data space will be having two components, that is space needed for constant and simple variables in a program, and space needed for dynamic allocation objects such as arrays and class instances. Okay, so that are created dynamically. Okay, so any doubt in this space complexity, how it is means which what exactly instruction and data space and what it has in this space complexity? Can we move forward?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So again, we have an environment stack space. Okay. So whenever you are going to run a program, so if you remember the recursive execution of your program, so again, okay, if you won't remember, still also, suppose already we have taken going to store, so that is going to store on a stack. Okay. So disconnect झालं का मी मध्ये?
Oh, sir.
Yes.
Okay, sorry. So where we are at this page, environment stack space. Yes.
Yes, sir.
Yes.
Okay. So basically what I am saying, okay, so environment stack means which are the environment stack, that is context switching is used to save the information needed to resume the execution of a particular completed functions. Okay. So you can say this stack space as, okay, so suppose if you are running a recursive program, or if you are working with an applications on your mobile, okay. So what happens, so whenever the one application is going to be paused, okay, so that current state of that application is going to store on what we'll say stack space, okay, of your computer. Okay, so if you consider, so this is the stack space of your computer. So whenever you are going to work with, suppose I am working with first thing I am working with YouTube. Okay, so I am working with YouTube over here. Okay, so whenever you get a WhatsApp call, so what happens, so this YouTube is going to be push on the stack and its instance, current instance. Okay, so whatever the video you are playing, okay, what are the time of the video, so it gets paused, but that instance is stored in stack space. Okay, so again, above to that, suppose we'll have a WhatsApp call, but on the WhatsApp call, okay, so we have received, okay, the normal call. So this status of the WhatsApp call or WhatsApp application also pushed into the memory, so that is over there. Okay, so that instance is saved. Okay, so suppose you have typed some message, okay, and immediately you get a normal call. Okay, so that will, so normal call is now running in a memory. Okay, so what happens, so every time extra space is created to that particular whatever the instance of the program is going on. Okay, so that is called the stack space. Okay, and once this particular first this call is going to be end, okay, so it will be automatically resume this call, WhatsApp call. Okay, so again, when it is finished, so it will be automatically resume your video. So whatever we have, so this space also we have to take into consideration. Okay, so while executing the program, so this is called as a stack space of your program. Okay, so getting the space, we have an instruction space, data space, and also we have a stack space. Okay, so basically these are instruction space and data space are two important part we have, and also we have to consider this environment stack space. So is it clear? These three things we have.
Yes.
Okay. And when it comes with the time complexity, basically we are more interested in time complexity than space complexity. Okay, already we have discussed previously also. Space, now we have abundant space. Okay, so we are now reached to petabytes more space we have. In normal computer also we have gigabytes of space at least. Okay, and our program does not that much need as compared to your time of your program, space is not that much, but we are focusing on both, but more focus is on time complexity. Okay, so basically what is the time complexity? Is the time needed by an algorithm that is expressed as a function of the size of a program, that is called the time complexity. Okay, so suppose you have written a 10 lines of code. Okay, so if you return a 10 lines of code, okay, so what is the time complexity? What exactly the time needed to compile that whole program? Okay, so what exactly the time needed? So suppose that is 1 millisecond. Okay, so initially, as per our normal basic understanding, I can say that this 10 lines of the code of a program will execute in 1 millisecond. Okay, so our basic things of consideration. Okay, so we'll see exactly that is not what we'll say exact thing that we are going to consider. Wait a minute. Okay, sorry. Okay, so basically the time is now with our basic understanding, you can consider it 1 millisecond. Okay, so suppose another time will be 1.01 milliseconds. We can differentiate the time like that. Okay, another program time will be 1.01 milliseconds. Okay, so likewise we can differentiate. So which is efficient? So this will be 1 millisecond will be efficient. By rough understanding, we are not going to calculate like this because we have a constant of calculating that particular things. Okay, so it's not feasible to calculate like this. But time is what it is time needed for an algorithm to run throughout the memory. Okay, so basically the time complexity of program is the amount of computer time, okay, that it needs to run the completion, that needs to run to the completion. Okay, again we can see the limiting behavior of the complexity as the size increases. So we are going to see this term in next upcoming lecture. That is, we are representing that time in some technical terms. Okay, so that is called as an asymptotic notations. Okay, so if you remember in last semester, we are writing O of n. Okay, so that is big O of n we are going to call. So this is called as an asymptotic notations. Okay, so we'll gradually reach to this. Okay, so this is called, so this behavior of the time complexity. So we are going to represent into this asymptotic time complexity or asymptotic notations. Okay, so this is about the time complexity. So we'll just go now in detail. Okay, how to calculate that all things together. Okay, so basically the goal of this subject, okay, so of data structure is to develop a skill for making an evaluation capability to judge the program. Okay, so how the program, whether that program is efficient, okay, whether that program is up to the mark. Okay, so that ability we have to develop, and we have to develop what we'll say an ability to write a program in such a way that, okay, so it should be developed in back end of your mind, so it will be developed with practice. Okay, so we have to develop an ability so that whatever the program we are going to write, okay, so that will be optimum. Okay, so that optimization we will get with time. Okay, so whatever the program we have written in first year, okay, so now whatever you are going to write in second year, so that should be somewhat optimum. Okay, so how you can judge a program basically? Okay, so we can say three criteria. So roughly we can say, okay, three criteria. Does it do what we want to do? Okay, so suppose if you are making a program for addition of two numbers, so it should do the same addition. Okay, it should not do some square of the program. It should not do some multiplication like this. Okay, it should be stick with that addition of the program. Okay, so that one thing we can say the program is now okay as it does what exactly it is intended for. Okay, so that is my first criteria I can say. Second, does it work correctly according to the original specification of the task? Okay, so what is the task originally specified, whether it works accordingly. Okay, so if we distinguish, you can say that both statement will be same. Okay, so I can okay, so just elaborate. Okay, so what is my output? I have to make an addition of two programs. Okay, so does it work correctly according to the original specification? So original specification is again given in detail. Okay, it should do an addition of integers. Okay, so what specification it is given, so whether it is working correctly on that specification, that is my second criteria. If we go in detail, okay, suppose I am doing some HTML code. Okay, so in that HTML code, someone told me to create a login page. Okay, so what is the task of login page? So how much elements we will find on login page? So I will have one username box. Yes. So I will have one username box. I will have one password box. Okay, and I will have one button for click on login and one button for reset. Yes. So these are the things you see on your login pane of any website. Yes or no?
Yes.
Yes, sir.
So the main task of this particular login is to make a login. Okay, so if it logins correctly for the correct input, so basically that will be, we can say it is indented. Okay, sorry, it does what it want to do. Okay, so my task is to make login. Okay, so but does it work correctly according to the original specification? So original specification is given, it should only log in with email ID. So it should not work with another any task. Okay, so that original specification I have to work with. Okay, so likewise, is there documentation that describe show to you use it and how it works? Okay, so is there any documentation is given? Okay, so how it is describing? Okay, so these are the some basic criteria, but still, okay, so we really roughly say that to judge any algorithm, we'll just see what exactly it is intended, it work accordingly, how many number of steps it is intended, so it is working on the same thing,
what exactly or theme of a program the program is going to achieve the same thing, so that we can roughly say this is the criteria. But it's not feasible to work on these criteria, okay, so because that are again user specific, that are again very difficult to judge, okay. So there are some other criteria that we already looked, so that by which we can judge an algorithm, that where we have more direct relationships, okay, so where we found a more direct relationship to the performance, okay. So these are the two things, that is space and time complexity, okay. So again, if we see, the space complexity means it is an amount of memory needed to run a completion. It should reach the completion of the program. Okay. So already we have seen. So suppose if I declared variables like int a, so what will be the space it is needed for this int a?
4 bytes.
Yes. So the space will be needed. So we can say it will be 4 bytes. Okay. So what we'll say, if it is a 64-bit system, otherwise in general say what we'll say general term, I will say one word memory. Okay. So you'll come across this technical some specification. I will say one word of memory. Okay. So one word is equivalent to your size of your operating system. Okay. So that will be one word. So for 32-bit system, it will be 2 bytes, and 64-bit system it will be 4 bytes. And again, if you have more increased size of system, it will be one word actually. It may be 2 bytes or 4 bytes. Okay, so I will have a one word of memory. Okay, so which is required. Okay, so basically the space complexity is exact the same thing that we are looking for. Okay, so now these are the three instances of the algorithm for which we will see how exactly the space is needed. Okay, for these all algorithms. Okay. So suppose these are A, B, C are three variables we have. Okay, so the size will be needed for A separately, B separately, and C separately. Okay. In this we have how many variables we have? In this we have S as a one variable. Okay, we have I as a one variable, and we will have an array over here. Okay, so that is one thing we are looking for. So this is the space we have, and here also how many space will require? So we'll require space of A, will require space of N, but it will be in multiples of this recursive call. Okay, so that we have. So these are the three scenarios. So we'll just go and look what exactly how we'll calculate this. Okay, again I'm telling that okay, space complexity we are not focusing that much. Okay, so but the moreover we are going to focus on time complexity, but we'll see how exactly it is to be calculated. Okay. So basically the space needed for each algorithm will be divided into again two parts. One is fixed part and one is variable part. Okay, so can you tell me in this algorithm, suppose I will tell this algorithm, so this algorithm. So tell me which is the fixed part as compared to the space, and which is the variable part, or which is changing. By looking at this, then we'll see what is fixed and what is variable. Which variable is fixed in this program? Any guess? Okay. Okay, so the fixed part will, you can say that is the S. S will be the fixed one. Okay, so this will be now one word size or 4 bytes we can say. Okay, and this A of I is dependent actually. Okay, so it is going to dependent on this N. Okay, so that is going to change according to N. Okay, so fixed part we can say this part you can say it is independent of the characteristics of the inputs and outputs. Okay, this part typically includes again your instruction space, simple variables that we are going to need. Okay, so that is called as a fixed part. Okay, so we'll have a space for a constant simple variables that will come across over here. Okay, and variable part that consists of space needed by the component or compound variable whose size is dependent on the particular problem instance being solved. Okay, so the space needed by the reference variable, you can say recursive stack space and all the things we'll have. Okay, so these are the two terms we have. Fixed part you can consider the fixed variables that we have, and variable part, so basically it is a dependent part of your program. Okay, so we'll specify like this. Okay, so how the space complexity will be given now? Okay, so that is SP. Okay, so that is space complexity we have. It is equal to C, that is the constant we have, plus you have this SP, that is the instance characteristics. Okay, so that moreover we are going to focus on the this variable part, okay, that we have. Okay, so if we consider all three these two at least last two programs we have. Okay, So how we'll calculate the size for this sum of a n? Okay, so if we calculate the sum of n, what it will be? Okay, so we'll just write. Okay, so how much size is needed for this a of I if n is there? Don't consider it as array, it is the dynamic you can consider. Okay, so one is needed for s, one word is needed for yes. Yes.
Yes, sir.
Okay, plus one word is needed for I. Yes.
Yes, sir.
Plus how many instances of a of I it is needed? It will be n. Yes.
Yes, sir.
Yes, sir.
Yes.
So if we see, okay, so how it is now will be there. Okay, so now it is 1 to n. Okay, so we will consider it is n or n plus 1 we can say. Okay, so it will run for one more time actually because we are working like this. Okay, so if we consider, okay, so how much space it is needed now? Okay, so it is we can say n. Okay, plus we can say 3. Okay, n we don't know. Okay, what exactly n is there? We don't know. Okay, so these many word size we need for this program. Okay, so this one word for this, one word size means 4 bytes for this. Okay, and again it will be n plus 1 size. We have to store like this. Okay, that n plus 1 size will have this one will be there, and this n will be what we'll say is dynamic. Okay, so it will need n plus 1 size. Everyone agree with this?
Yes, sir.
Yes, sir.
Yes.
Okay, so suppose the n size will be 10. Okay, so it will be 10 plus 3, so that is 13 bytes. Sorry, 13 into 4 bytes of memory will need, or we can say 13 word memory to be stored for as a space over here. It is needed. Okay, any doubt in this? How it is calculated?
No, sir.
Okay, so that will be the space complexity for this. Okay, so if we go for this, okay, so now we'll see. Okay, so it is written if n is less than or equal to 0. Okay, then return this something 0.0. Okay, so that will have. Okay, so now how much space we are going to need? We have. So for every return statement. Okay, tell me how many variables are there in return statement? Is the return statement? Yes. How many? Okay, so a is there. Every return statement will have a, yes or no?
Yes, sir.
Okay, plus which is what is the next variable we have over here?
N.
N is there, correct? Yes, N is there. And any other variable you are looking over here?
A of n.
Okay, A of n. Okay, so yes, A of n, but instead of A of n, may I say like address of A? Yes, address of A we need.
Yes, sir.
Okay, because we are always we are making n minus 1 and so on, it is going to work with. Okay, so we can say E of n or address of this particular thing. Okay, so how much it will be now? Okay, so this particular thing we can say this will require one word. Okay, this will require one word. Okay, and this will require one word. Okay, so how many words we now have for one instance? It will be 3. Yes.
Yes, sir.
Okay, and how many times this particular whole what we'll say recursion will run? It will be n plus 1 if n is there, and we have to check for n is greater than or equal to 0. So it is also going to check for 0. So will it work for n plus 1 or will it work for only n?
N plus 1.
N plus 1, sir.
Okay, so got how the this particular thing we have calculated? 3n plus 1 will be there. Okay, got correctly how it is calculated?
Yes, sir.
Okay, so by this way, we are going to calculate the space complexity. Okay, so this is the way by which we are going to calculate. So recursive stack space will be greater than or equal to 3n plus 1. Okay, so that we have to remember. Okay, and this will be greater than or equal to n plus 1, no, n plus 3 only. Okay, so for this particular thing. Okay, and specifically for the first instance, we are dealing. Okay, so basically these all ABC will be there. Okay, so we are now in this particular formula. Okay, we are only dealing or interested in instance characteristics, which are something dependent characteristics. Okay, here all are independent. Okay, ABC all are independent. Okay, so you can consider three words or you can also consider zero here. Okay, so because they are not dependent. Okay, so means what it means actually, it will not much. Means taking that into consideration will not have much effect on our computation. Okay, so that we have. So is it clear what is that space complexity and how it is calculated? Okay, so can we move forward if it is clear?
Yes, sir.
Okay. So now in your what we'll say exam and also, okay, you may have given few problems, okay, like this, algorithms like this, okay, and you may have to find out the space complexity. So it's very simple. Okay, so you have to just check how many variables are there, okay, and you have to just sum up that variables. That is the space complexity actually. Okay, how much space exactly needed, and you know variable that if it is written like a normal program. Okay, so suppose if we write a small program, it may be a pseudocode or a program, we can say. Okay, so suppose if we have written a program like suppose integer a, integer b, okay, and I will write for I equal to 0, I less than n, I plus plus, okay, and we will see a is equal to a plus, we can say sum is equal to a, this sum plus a of I. Suppose I have written like this. Okay, so we'll have this AB is not needed. I will write just int sum equal to 0. So likewise, if it is written, how much space is needed? Sum like it again. So sum will be having one space is needed. Yes. Again the same thing. Same. I think I have taken same example. I will be needed one thing. Okay. And this a of I. Okay. So means what? A of something. Okay, I will write this question mark. Okay, it is needed n space, n plus 1 space, we can say. Yes?
Yes, sir.
Okay, so total space will be, this will be 1 plus n plus 1. So it will be n plus 3. So it is not exactly equal. You can say it should be greater than or equal to n plus 3. Okay, so it should not be less than n plus 3. Okay, it may be having more space also with regards to other space of our memory which we require. Okay, so is it clear how we are calculating this space complexity? Okay. Okay, so this is about space complexity. So now we'll move for the next part, that is time complexity, and on the basis of time complexity, we have asymptotic notations that we have to look for. This is also very simple thing. Okay, so we have. Okay, so basically, what is the time complexity? Okay, so it is represented as CP, that is time taken by a program P with the sum of compile time and runtime or execution time of that particular program. Okay, so you know that what is compile time and what is execution time. Okay, so compile time means what? Once it is created the object file, and execution time will be the time which is needed to execute that whole program. Okay, so which time will be greater, compile time or execution time? If you see a normal program, which time needs much time?
Execution.
Yes, correct. Execution time will be having more time because compile time will just create its compiled version of a program. Okay, so it may be object or machine specific program it is created, but execution time will require much time. Okay, so when you execute actual program, so which part we have to focus more, compile time or execution time?
Execution time.
Execution time.
So moreover we are going to focus on execution time. Basically, this is one formula which is given. So specifically, we can calculate the time complexity also in number of ways. There are a number of ways we can calculate time complexity. So suppose I will just calculate the time needed for addition. Okay, so of n elements, time needed for subtraction of n elements. Okay, time needed for multiplication, time needed for division, and a number of operations of our respective operating system. We can try to calculate. Okay, so how much time it is needed for addition, how much time it is needed by that particular operating system for subtraction, how much time it is needed for multiplication and division, and so on. Okay, so that one way we can calculate this CA will be constant for that particular thing. Okay, so we have. Okay, but obtaining such exact formula is impossible task. Okay, so because everything it is what we'll say, the addition and subtraction will be the multiple additions can be there, multiple subtractions. It will not always be fixed as n. Okay, it can be a addition of two numbers, one, okay, subtraction can be subtraction of four numbers, okay, so like that we have, okay. So it is not again fixed, and again it is depending on the what we say operating system we are going to use, okay. So somewhere we are not able to find out the exact solution with this particular formula, okay. So that is not an optimum way to find out the time complexity with respect to the program, okay. So what we'll do instead of that, we'll count only the number of program steps, okay, irrespective of what will the system you are going to use, irrespective of whatever the compiler you are going to use, irrespective of what is the language you are going to use, okay. So what we are going to calculate, we are going to calculate the number of program steps we need to run a program, okay. So now in this all three algorithms, what we exactly interested in, we are going to interested in the number of steps in a program, okay. So on the basis of that, we are going to calculate the time complexity, okay. So now what do we mean by program step? Basically, program state, it is loosely defined as a syntactically or semantically meaningful segment of a program, okay, that has an execution time that is independent of the instance of characteristics of other program, okay. So if we see in this program, so this whole step, okay, is independent, yes or no? It is not depending on any other thing. Like this step is dependent. Yes?
Yes, sir.
Okay.
Yes, sir.
So basically this is independent step. Okay. So how much lengthy step it will be? I will call it as a one step. Okay. So it may be having few multiplication, few subtraction, division, but I will be call it as a one program step. Okay. Getting what is a program step exactly? This is the one program step. Clear?
Yes, sir.
Okay.
Yes, sir.
So this is also program step basically, but that is dependent on this. Okay. So for how much times it is executed, I have to go through this for loop. Okay. So that for loop I have to calculate. Okay. So on the basis of that, we'll just calculate how much steps. Okay. So this is considered as one program step initially. Okay. But only program step is not sufficient for this statement. I have to also check the how frequency of that particular step. Okay, so what is the frequency of that particular step? It is n is the frequency of the step. So the execution time or for this particular step, it will be n. Getting? Hello?
Yes, sir.
Okay, so likewise it is depending on, okay. So we have to calculate like this whenever it comes to the time complexity, we are going to calculate like this, okay. There are a number of approaches by which we are going to calculate the time complexity. One approach is that put count variable in between. Okay, so put count variable in between. So what we'll do, we'll calculate time complexity of bubble sort, okay, with the inclusion of some count variable. So we'll see the three examples for normal bubble sort, then we'll have that n minus I bubble sort, and we'll have the advanced bubble sort. Okay, so I will have some. Anything getting difficult? समझत नहीं है, slow होते, fast होते. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
I will take a count variable. I will initialize it to 0. I will for integer I equal to 0. I less than suppose I will say some variables 10 or we can say n I plus plus. Okay, I will make for j equal to 0, j less than n, j plus plus. Okay, and we will say if array of j is greater than array of j plus 1. Okay, so we have to swap that. Okay, so for swapping, I will write temp equal to array of j. Array of j is equal to array of j plus 1. Okay, array of j plus 1 is equal to temp. Okay, so that is my program, and only this variable you have to declare. Okay, so that will be integer temp. Okay, then I is already declared, and I will just see integer n is to be declared, and I will write n is equal to 10. I will write, okay, and I will make integer array of 10 is equal to 2, 3, 6, 6, 55, 11, 20, 45, 98, okay, 34, 12. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what I will do, I will just keep this last element sorted. So we'll just see any difference. Okay. So this is my particular normal bubble sort. Okay. So once the execution is over, I will just check, okay, whether it will give us the correct output or not.
Sir, line number 7, there is a typo.
Dot alaka.
Yes,
Oh,
sir.
thank you. Okay. So we'll just see for, okay, integer I equal to 0, I less than n, I plus plus, and we'll just see printf. Okay, so we'll just see space. I will make %d array of I. I think it's correct. We'll just see the execution. So that I will integer array. Okay, so now it is correctly sorted. So I will introduce this count variable. So I will just make for every sorting. I will make okay. So whatever we have to write. Okay, so basically, okay, now where to introduce actually this count variable, I will just tell you. Okay, so first I will just tell the difference. It will not to be included only over here, but just to make a difference, okay, between these three algorithms to check its efficiency. We'll just add one count, then we'll see where exactly we have to add the count. So I will just write count is equal to plus count. Okay, so if I run this, so I will get I don't know. Sorry, I will given plus over here and percentage remain. ఇప్పుడు జావా చల్లని జావా పని మొదలు it should be n minus 1.
Sir, line number 21,
This number of
and array of I.
Where are they?
Sir, and array of.
नहीं and
Okay,
figure
sorry, sir.
print करते हैं ना अपन ठीक है. So we'll just come out of this. It is number of comparison, but we'll just see the number of passes we need. If I just calculate this, so okay. So we'll just see first the number of comparisons we'll need. The comparisons will be the same, I think. We'll just see this count only. Okay, so we'll see this for this normal bubble sort, it will be 90. Here I will make n minus I. So what it will make? It will make 55. So getting the difference, so the reduced count will be 55. Yes?
Yes, sir.
Okay. And finally, what we'll do, we'll just see some advanced thing. I will just add a flag over here. Flag is equal to 1. Okay. And I will make flag equal to 0 over here inside this for loop. Okay, no issue. Flag equal to 0. And once the end of this inside J loop, okay, I will say if flag equal to 1. So I will make break. Okay, so means what? If everything is sorted, so no need to go sorting again. Okay, so that will be there. So what happens again? Stack terminated. Is equal to 10. Where it is terminating, here should be 0 to n minus I. N is correct. 3, something is missing. Let's check. I is equal to 0, I less than n, j is equal to 0, j is less than n minus I. Okay, so no issue, that should be. Okay, so getting, so only 9 steps we'll need over here. Getting the difference between these three executions, okay? So with this introduction of this flag, okay, so we just go with this 9. If I remove this flag and if I run this, okay, so I will need 45 number of what will say steps. Okay, so that is not actually steps, okay, but for 45 number of iterations I will need. Okay, And if I remove this I also, n minus I also, and if I run this, so then I will get 90. So getting the difference, how much difference we have in these three algorithms?
Yes, sir.
Okay,
Yes,
so
sir.
that if so that we have worked as it is. Okay, so like that. Okay, but this way we can introduce the count over here, but this is not exactly where only we have to use. Okay, so we just see where we have to use this count variable. Okay, so suppose if you see this particular thing. Okay, so wherever we have to use the count variable, because you see, okay, already I have told you. Okay, so this particularly will call as a one step. Okay, so this is my one step. Okay, so any declaration will be one step. Okay, so everywhere we have to write. Okay, so like that. Okay, so here this s is equal to 0, so that is my one step. Okay, so I have to increment count over here, so that is count is equal to count plus plus. Okay, so that we have. Again, this for we have to make some initialization and checking, so this for is also one step. Okay, so there also I have to add count. Okay, inside for this initialize this addition also one step, so I have to add count over here. Okay, and finally whenever it came out of this for loop. Okay, so it is again it will check the condition, so for that I have to make one count, and for this return I have to make one count. Okay, so for every statement which we have, I have to add one count everywhere. Yes or no? Getting?
Yes, sir.
Yes, sir.
So for any, if I will increase this program, okay, so I will make count plus plus over here. Okay, that is one step I will need over here. Again, for this I will make count plus plus. For this one line I will have this. Okay, again I will make this count plus plus. Okay, so that is added. Okay, again for this one for loop I will have count plus plus. Okay, again for this internal this for loop I will have count plus plus. Okay, okay, you say that this is very rigid. Okay, we'll have some good again one methodology we'll see. Okay, so this count plus plus will add. Again for this if comparison I will add one count plus plus. For this 1 2 3 4 I will make direct count is equal to count plus 4. Is it correct? Because we have 4 plus plus. Okay, then again we'll have I will just remove this count over here. Again for this end of this for loop I will have one count plus plus. Okay, so that is added over here. Again end of this for loop I will add one count plus plus over here. Okay, so let's see. Okay, rest of the thing will print. We'll have again this for print. We'll have this for loop I will have one count plus plus. Again I will have this one count plus plus over here. Okay, so that will be again this printf I will have one count plus plus. Okay, so these many count plus plus we have to add. Okay, so if you run this particular thing, so how many total number of steps we have? 170 steps in this program. Getting?
Yes, sir.
Hello. Okay, so likewise. Okay, so if I made it again here minus I, so you are improvising your program. Okay, so how many steps will need exactly? It is 125. Okay, and if I have added over here if flag equal to 1, then break. Okay, so it will work like this. So it will be having 61 only
सर
steps.
क्या इतना अपना अकाउंट प्लस प्लस
कशाला?
इथला
हाँ या इथला आहे ना. हाँ बरोबर. इथे काउंट आहे 62 इथे. ठीक आहे. Getting?
Yes, sir.
yes
Okay, so so this is the time complexity. Okay, so how you are going to improvise your what will say program. So what we are going to calculate, we are going to calculate how many number of steps we are having for execution of that particular program. Okay, so on the basis of that particular count, we are checking whether our program is efficient or not. Okay, so now as we have discussed, okay, so these all three algorithms are giving us a correct output. Okay, so nowhere we'll get a wrong output. Okay, so everywhere the data is sorted. Okay, only the difference is getting in count. Okay, so now where you have to focus, you know sorting, you have to focus on this minimizing the number of steps which are required for running this program. Okay, so that we have again for more what we'll say, we can also reduce one variable from over here. Okay, so whenever you will go for some advanced things, okay, I don't exactly what we'll say, in some advanced things it is used. Okay, so suppose I will tell you one scenario for space complexity. I will remove this. Okay, so space, or we can say time complexity. In more advanced way, it is not actually calculated, but if you have to prepare something more advanced thing, okay. So I will write, we are making A is equal to A into A. Okay, this you may come, I exactly won't know exactly in which subject, but in operating system in subject will come across this. Okay, you have a subject DCO na this semester, D
Yes,
and
sir.
CO, digital electronics and
Yes, sir.
computer
Yes, sir.
organization.
Yes.
You may come across this concept. Okay, so now basically this is the multiplication. Okay, so what it will do? Okay, so suppose my A is equal to 2. So what is my answer here? It is 4. Yes. If A is equal to 4, my answer will be 16. Yes. So
Yes,
what it will do? It will square of that particular number. So can I do with this operation? You know,
Sir, left shift, no? Right
it is
shift.
a left shift actually. Okay. So thoda advance सांगते मी. Okay. So this is a left shift operation. Okay. So what happens exactly in left shift? Okay, we'll do it programmatically instead of that. Okay. So I will write. किती वाजले? वेळ आहे ना आपल्याला?
नाही सर. सर 12:15 पर्यंत sir.
एक 2 मिनिटात संपव. .h. तुम्हाला बेसिक मल्टिप्लिकेशन माहिती ते काही लिहित नाही मी. I will write int a is equal to 2. Okay, and I will make a printf. Okay, I will make a %d comma a left shift 1. So we'll see what is the output. For getting 4, I will make 4. So it will give us 8. Okay, I think it is 8. Yes, 4 like it will be 8. Okay, so if I will give 3, 6 will make it like this. I think it is 2. 4 into 4 it is 16. How you had one? 2. Okay, what happens actually? Wait a minute, I will just. Okay, it is basically multiplied by 2. I have just written square. Okay, so getting, so 3 is multiplied by 2, it is 6, and 3 left shift 1 also 6. Getting? Okay, so if I written 5, so then 5 multiplied by 2 is also 10, and 5 left shift also 10. Okay, you can take any number, it will be multiplied by 2. So suppose if I have taken 100, suppose I have taken 125, so it is multiplied by 2, so it is 250. Getting?
yes, sir.
Okay, so suppose if we take 2 over here also, suppose I have written 3 over here, and if I have taken 2 over here, so likewise it is going to work with. Okay, so likewise it is multiplied by 4, something like that. Okay, so what is my intention to tell? So I can write like this also, a is equal to a into 2. Okay, so that is one step, and we are going to write a left shift 1. Okay, so both will give us the same output. Is it clear to everyone?
Yes, sir.
These are some advanced programming practices. This is not a part of this syllabus, but you may come across. Okay. So what happens in backend? Okay. So your multiplication requires much time than left shift. Okay. So why I am explaining this? Your multiplication will require more time in compiler time actually. Okay. At your operating system time, multiplication will require more time than left shift. So you may code that. Okay. I use this left shift because it will have some less time which is required. Okay. So likewise, you can improvise your programming skills. Okay. So it depends how you'll going to adapt that particular things. Okay. So hope all things clear with this time complexity, space complexity and all. Yes?
Yes, sir.
Okay. So tomorrow we'll continue with that count. Okay. So we'll just go through 1 or 2, what we'll say count examples. With count variable, we'll see 1 or 2 examples. Okay. And after that, we'll have one table, count table we have to generate, where we won't have to add that count variable programmatically to check that thing. We can directly with our small table, we can calculate the exact frequency. Once that frequency count means the total number of steps is completed, then we'll say what is exactly asymptotic notations and why it is important and what is required. Okay, so thank you very much. So we'll meet again in next week. Okay, hello, bye.
Thank you.
Thank you, sir.